All right, calculus, cave women and cave men, cave people. We're going to go ahead now and do example 2 underneath higher derivatives and concavity. And, once again, we have our function. We're going to find increase, decrease, max, min, concavity. We're going to use that information to build a graph. So we've already talked about the fact that max, min, increase, decrease, that's all what's called the first derivative test. So again, we take the first derivative called f prime, 15x to the 4th power minus 80x to the 3rd power, and then the 1,000, of course, drops off. And we set it equal to 0. 15x to the 4th minus 80x cubed equals 0. You guys know what I'm about to say, right? Solving this equation is just algebra. All right, so I reviewed algebra with you, but I can't do that much more. So let's see, what can we do? We can factor out, I believe, a 5x cubed, and that would leave 3x minus 16 equals 0. Let's double check. 15x to the 4th minus 80x cubed. It would serve me right if I mess up in my algebra. All right, and so anyway, 5x cubed equals 0. Once you factor it, that leads to x equals 0. And then 3x minus 16 equals 0. That leads to x equals 16 over 3, otherwise known as 5.3 repeating, right? 5 1/3. So I'm nervous as heck that I'm going to make an algebra mistake and you'll forever be able to make fun of me. Just algebra. But anyway, so we have those two, and they are critical. That's the language we use when we do the first derivative test. So we will put 0 and 5.3 repeating, and we'll identify the fact that those are places where the first derivative is 0, indicative of horizontal tangent lines. The first derivative gives us slopes of tangent lines, as it always has. Now, we will test numbers. That's why it's called the first derivative test. -1, -10, anything. In the first derivative, so -1 to the 4th power is +1 times 15, that'd be 15. And -1 to the 3rd power is, why am I blitzing? -1 times 8, that's plus 80. That's going to be a positive. So that first derivative is positive, indicative of positively sloped tangent lines, which, as we've discussed, means increase. So, from -infinity to 0, and I want to remind you that these would be intervals, wouldn't they, on the x-axis. All right, now we pick a number between 0 and 5.3, and we test it in the derivative. It's like going on a date with it to see whether it gives us a positive or a negative relationship. Let's put 1 into the derivative, f prime. 1 to the 4th power is 1 times 15, that's 15. And then 1 cubed times -80 is minus 80. That's going to be a negative number. Doesn't matter, it's -65, but who cares? It's negative. Negative, negative, negative. Downward slope. All right, decrease. This is all old stuff. I guess old in terms of a previous assignment, right? Okay. Flashback. F prime of, I'm going to pick 10 because it lives out there, and 10 usually is good arithmetic. Let's see. 10 to the 4th power, 10, 100, 1,000, 10,000. 10,000 times 15 is 150,000. Let's see. 10 cubed. You're welcome! 10 cubed is 1,000. That'd be -80,000. That'd be a positive number, won't it? Okay, so that first derivative is positive for all numbers out there. I put multiple plus signs to indicate every number out there would have a positively sloped tangent line, and therefore, from 5.3 to infinity, this thing increases, doesn't it? So let's identify those things. That's what we're looking for when we grade these. We're going to make these questions worth multiple points, because obviously they have several parts to them. And yeah, there'll be some partial credit if you get things right, but you miss silly stuff. Okay, as far as maxes and mins, you need points, don't you? So I always come down here and go, ordered pair, 0. You put that in a function, don't you? All right, so 0 here, 0 here. That would end up being 1,000. And 0, 1,000 is a maximum, isn't it? These are all positively sloped out here. All right, so that's a max, as discussed before. Just remember that if it increases coming in and decreases going out, it's a peak, it's a high point, it's a maximum, a relative max. Let's close off the point there, all right? Boom, all right, these markers, they keep going. So much excitement. All right, 5 1/3, 5.3 repeating, right? Put that in the function. All righty, so, boy, this is exciting to watch the old man do this. Let's see, we're putting it in the function, right? So 3 times that number to the 5th power minus 20 times that number to the 4th power. I'm nervous. You guys wishing me luck? Or are you hoping that I mess up? All right. How about on the count of 3, we say what numbers we got, okay? Ready? 1, 2, 3. Okay, I cheated. I wanted you to talk first so that I can hear what you said and say, yeah, I agree. Negative 2,236. Point blah blah. Yeah, that's what we got, right? Let's see. By the way, I put 5.3333 forever in there. I'm double checking. Yeah, I think that's good. All right, now what? Minimum, isn't it? Wouldn't that give us a minimum type of point here? So, 5 1/3, comma, negative 2236. Boom. First derivative. Been there, done that. Okay? What's new again in this section is the discussion of concavity. So, we do the second derivative. We take the derivative of the first derivative, f double prime. That would be 60 x cubed minus 240 x squared. Let me do 4 times 15, 60, x, power rule. All right, I think that's good. Same thing. Let's take care of undefined. All right, we're keeping it easy. Undefined. There's no fractions. We don't need to worry about that. All right, so we'll set it equal to 0. We'll set that second derivative equal to 0. 60x cubed minus 240x squared. You guys know what I'm saying. This is, okay, what's he going to say now? Solving this thing for x. 1, 2, 3. Just algebra. All right, so you factor out 60x squared, and that would leave x minus 4. That gives us 2 factors here. Boy, if I mess up on the just algebra, oh my gosh. That's why I'm losing sleep right now. All right, so anyway, when you set each of these equal to 0, I'll tell you what, there's people who have bigger problems than that. So I'm lucky if I lose sleep over worrying about my algebra. But that'll be 0, that'll be 4. Okay, not a big deal, hopefully. So I like to draw a number line to show that we are looking at values of x and how they behave in f double prime. This is why I like to label these. These are x's, these are f primes. These are x's, these are f double primes. And so we've got 0 and 4, okay? And the second derivative is 0 at those 2 places. And we test them, right? F double prime, how about negative 1? Negative 1 cubed is negative 1. Times 60, that'd be negative 60, and then negative 1 squared is positive 1, and positive 1, that'd be minus 240, and it looks to me like the second derivative would be indeed negative out here, and let's remember that means concave down, all right? Less than 0, concave down. Let's put that over here. From negative infinity to 0, that interval we just tested, concave down. F prime of 1, or you could do pi, 3.141592653, that's in there, pi. I'm going to do 1. All right, 1 cubed is 1 times 60, 60. 1 squared is 1, minus 240. Well, that's also negative. I'll be darned. Still concave down, isn't it? Yeah, okay, sorry. So from 0 to 4, it's still concave down, isn't it? And that's interesting. See, the concavity did not change at the 0 there, did it? And that comes into play as we move forward. All right? And then f double prime of, how about 10? We're in 10's neighborhood here. All right, let's see. 10 cubed. You're welcome! 10 cubed is 1,000. And 1,000 times 60 is 60,000. Minus, let's see, 10 squared is 100. So 100 times that would be 240 times 100. 24,000. And that's positive. Concave up. Just think of a parabola opening upward. All right? So, from 4 to infinity, concave up. There we go. All right, so we got that one. And we have basically what most people would tell you would be the information you need to get a pretty decent graph going. So I invite you to hit pause and catch up if you need to, whatever you want to do. But anyway, Mr. Sour Cream is going to go ahead and begin building a graph of that function now, as we are asking you to do. Just want to remind you, when you get the upload, you'll have the function, you'll have all that information. I think I gave you a whole page to do all this, and a whole separate page to do the graph. All right, so I'm envious of you. You're going to have plenty of space here, whereas I'm kind of hemmed in a little bit. But you know what? I'm going to make it work. It'll be totally fine. Okay. So, in terms of determining the appropriate scale, on the x-axis, look at the values of x, 0, 5, 0, 4. All right, once again, I think that 1s would be appropriate here. So 0 and 1, 2, 3, 4, 5, -1, -2, -3. Okay. As far as the y-axis, let's look at some of the ordered pairs. Oh, wait, we haven't found ordered pairs yet. I got ahead of myself. We have these two, but, sorry, I got ahead of myself. That's okay. We'll backtrack. Let's look for points that are associated with these numbers here. So 0, all right, if you put 0 in the function, it'll provide 1,000. By the way, that's here, okay. 4, well, let's talk about this. Hold on a second. Man, I'm getting so excited. Is that a point of inflection? The second derivative was 0, but did the concavity change? No! See, that second derivative did not change at 0. It was negative, negative. Concave down, concave down. That's not an inflection point. It's going to be a point on the graph. It's just not considered inflection. So no, we're not going to put it in that box over there. Don't put it in the box. It's not an inflection point. All right, but what about 4? Well, first of all, yes, the concavity changes. It's going to be an inflection point. And let's put it into the function to see what point that would generate on the graph. So, let's see. 3 times 4 to the 5th power minus 20 times 4 to the 4th power plus 1,000. 3 times 4 to the 5th minus 20 times 4 to the 4th plus 1,000 is negative 1,048. And yes, that's an inflection point. 4, comma, negative 1048. Boom. Yep. That is indeed an inflection because the concavity changed. So I'll say it again. That's not an inflection. That one is. All right, now let's plot them. I am looking at let's look at those y values to figure out a good scale here. Okay? What would be a good scale for y? 1,000, 2,000-ish, 1,000-ish, 1,000-ish, 1,000, 500. Let's go with 500. Okay, so 500. So, let's see, upward, we gotta make sure to accommodate 1,000, basically. And downward, I might regret my choice of 500 here. So, extend this a little bit. So that'd be -500, -1,000, -1,500, -2,000. All right, let's start plotting things. 0, 1,000. 5.3-ish, -2,200-ish. 1, 2, 3, 4, 5.3. A little bit below -2,000 here. Okay, max min. Okay, then we've already got this point again. So 4, -1,048, 4, -1048. Right about there. Look, use this as your rough guide and then just hit these points as you do so. That's what I would suggest. So, what do we got? We got increase, and we got decrease, hitting the inflection upon the way, down to here, and then increase again. You know, things don't change in terms of that first derivative, horizontal tangent lines. These were 2 points where the tangent lines were horizontal, okay? Maxes and mins, just like they've always been. This thing here is a hard thing to tell. This is that point where the concavity changed. So my take on this, as far as concavity, is concave down, and then it switched to concave up beyond that. That's not an inflection point because the concavity didn't change. Again, you don't need the red and green and all the boxes and the red stuff. I'm just trying to give you a visual of what's going on with that. So anyway, I would suggest to you that that should be good enough information for you to do this entire assignment. And we might not do another example. I'm going to decide after I hit pause here. I think you have everything you need to basically pull together this assignment. So I wish you the best. This is so easy, even a cave person can do it, right? Arr, arr. Arr.